Welcome back to the Home Lab, and I've got another interesting bit of science to share with you today. What we're going to look at is punched computer data storage tape. Recently, as you know, I've made quite a few videos on vintage computing technology and particularly memory storage methods. I had a lot of fun making a working core rope memory, and we've also looked at magnetic core memory and particularly the IBM punched card system. But today I want to share with you something slightly different. What I'd like to look at is what is computer punched tape, what was it used for, and how did it work? But as ever, just before we start, I want to say another huge thank you to all of you for watching and supporting my channel, and also for the wonderful comments that you leave. And this video particularly, I'm expecting some comments because I think some of you will be familiar with this technology and know a lot more about the technology than I do. And I'm really looking forward to what you've got to say and your experiences. So to begin with, a little story, and holding up this tape, I'm reminded of the fact that when I was a kid, probably in the 1980s, that sort of period, my dad, who was fantastic, he took me to lots of interesting places, took me to the museum at Jodrell Bank, the massive telescope that's not so far away from where we lived. And I was totally enthralled by a punched tape machine. That's a machine that was punching the tape, not reading it. Now, I'm not sure whether it was actually attached to the telescope or whether it was a sort of simulation, but I think it was genuinely the data coming down from certainly one of the telescope feeds. And I watched this tape come out, and you could tear it off and take a piece home. And it seemed to be much whiter than this tape is now. And I was just totally thrilled by it. I'm not sure I really understood what it was or how to read it. And there's no explaining my brain as a child. But I took it home and spent ages sort of looking at it and sort of marvelling over what it was and what I brought back. It makes a point, by the way, if you're a teacher or a museum, always let kids take something home with them because that sort of encourages the interest. Anyway, no idea what happened to that bit of tape or what data it had on it. Does anyone remember the same display at Jodrell Bank? But what we're going to do today is have a look at this very interesting tape that's come from a completely different source. So let's have a look at the tape that I've got. Now, this is Soviet era. I got it from Lithuania, and I don't really know very much about it at all. But it came with this documentation from 1976 saying reception control, I think, technical description and instruction. But my Russian's not really up to it, so I'll take a copy of these and you can have a go yourself. Anyway, I've seen boxes exactly like this containing reels of punched tape on documentary videos about Chernobyl. The boxes might have been a different colour, but they looked absolutely identical. And you'll notice in here is our reel of punched tape. I'm going to be quite careful to get it out, it's quite tight. With some writing on it as well. And again, I don't really know what that means, but those of you who are a bit better at Russian might recognise it. So what we're going to do is unravel a bit of this tape, and I'm going to explain to you what all these holes are to begin with and how this type of tape stored data. As I said, I don't know a great deal about this, but because it was kept in a canister like this, possibly with this documentation, I don't know if it actually belongs to the tape itself, it must have been quite important. And so it's probably not just data from an experiment. It's probably an individual program stored on the tape, or it could be a sort of bootloader that you have to put in the computer first to get it going. So before I unravel it, the first thing you'll notice is this relatively neatly cut end. And on the machine that made these tapes, there was actually a set of blades that you could sort of tear against, both to tear off the tape when it was finished, which left a sort of tail on it, and then the next bit of tape would have this arrow. And that has an advantage as well, that it shows you which way to load the tape, in other words, which bit is the front. But I'm going to show you in a minute how to make sure you don't get it in upside down. So whilst my tape is from the former Soviet Union, It's typical of all tapes of that period. It's punched onto 1-inch paper, and it was a really good quality paper, so that survived quite well. And you see these little holes in it to begin with. The paper's 0.1 millimeter thick, and these holes are 1.2 millimeters in diameter. So what we'll do is pop off this clip. It's a paper clip. That will have rusted onto the tape a little bit, and so it's quite tricky to get out. There we go. And we'll unravel a little bit of the tape, so you can clearly see the cut end, the arrow at the front, some writing on there, and some of you might know what that really refers to. And then these little holes, and you'll notice they're offset from the centre, and that's quite important because that means that we can't put the tape into the reader the wrong way up, because the holes wouldn't line up with one of two things: a little gear that drove the tape through, or an optical sensor that counted all the little dots, and that was used for synchronization. So even if the tape speed varied a little bit, the data could be read off reasonably clearly. So what we'll do now is have a look at how the data was put onto this 1-inch tape, and you'll see that the holes are a little bit larger in diameter. So, unravelling a bit, this is all leader to get it loaded into the machine, and there you go, you can begin to see some data. I find it sort of iconic of computing. I find it really quite pretty, and if you see this sort of thing, you immediately think of old-fashioned computers. And you'll notice the data holes are bigger in diameter. They're 1.8 millimeter holes. And you'll notice also that there's 3 on this side of the little holes, which are used to pull it through or to synchronize it. And then if you count 1, 2, 1 missing, 3, 4, 5, so 5 on the other side. So that's a total of 8 bits that could be stored in one column, shall we call it, across the tape, because of course the tape was moving this way through the reader. The other thing you need to know is that any 8 bits across the tape in the form of a column stored data in the form of 1s and 0s, obviously, and you've got a 1 if it's punched out and a 0 if it's not punched out. The other thing we're going to do is we're going to look at how many dots are stored across the tape in each 8-bit string, as it were. We're going to count those, and we'll also have a go at seeing what the coding might be on this tape. So, as I said, a good way to think about this is a bit like the magnetic tape that came later, that the strings of 1s and 0s stored on the tape, and in this case the 1s and 0s are stored by holes or places where there isn't a hole punched. And there were different versions of this type of tape. Those that had different numbers of holes punched, some only had 5 bits and then these small holes to drive it through and synchronize it. This is the 8-bit per column one. And there were also different types of paper. Originally, to make it run through really quickly, the paper was slightly oily, and that caused all sorts of problems with jamming and dust and little bits of paper getting stuck in the machines. So this dry paper worked much better, and I couldn't even begin to think how many millions of miles of this has been produced by computer scientists over the years. The other thing was that for industrial applications where the tape was being put on again and again, particularly in slightly dirty environments where there was computer-aided machining or something like that, the tape was made a bit more strong, a bit more solid, and they used mylar that you couldn't see through, only where the holes were. And that mylar, I haven't got any, but it sort of looked sort of a grey colour, sort of silvered, and any of you who've done machining might have seen that kind of tape. Oh, it's worth mentioning that the tape that was used on the computer-aided machining machines, that was mylar, because it worked so well and no one was going to update really expensive machines, I'm told that it was used well into the 1990s. So if any of you remember using it, or could you possibly still be using it, do let me know in the comments. That would be absolutely fascinating. The The tape itself was made from blank 1-inch tape, and a punching machine was used to punch out the holes. And punching was actually rather slower than reading. In fact, I'm told that the Colossus code-breaking machine was run at all sorts of crazy speeds, but was set finally to run at 500 characters per second. So that's 500 of these 8-bit strings here per second. So the tape was literally whizzing through at miles per hour. The other thing you could do on teletypewriter machines was you could type in what you wanted first, get all the errors out of it, and then send it to a punching machine, and the punching machine would punch away. But it was still slower than the reading machines. Now, one of the problems with this was all these little holes produced waste material, chad as it's called, and that fell into a big bin below the punch machine. But if any of you have worked with shredded paper before, you'll know the bits got everywhere, and the bits jammed in the machines and got all over the place where they were punching, quite often the same room where the computers were, which isn't really a good thing. So there were tapes invented that were chadless, and what you did instead was you punched through a sort of a little lid, I suppose, a little flap, so it wasn't punched all the way through, it's sort of 3/4 punched. And those could be read, instead of optically, they could be read with leaf springs and things like that. But the trouble was the tape became a bit more three-dimensional, and it wouldn't wrap very well, and it would catch. So that wasn't a particularly effective system. But there was never really a good way to get rid of all this chad, other than to sweep it up, chuck it in the chad bucket, and try and get rid of as much of it as you could. Let's look a bit more closely now at how coding was done on this tape. And you've got a good idea already that the larger holes represent ones, and where there isn't a hole, it's a 0. And there were two main types of tape. Those that used 8 holes across the width, and those that used 5 holes. And this is an 8-hole system. I actually have no idea what kind of coding this is. I was slightly surprised because there was a method that showed up errors. It wasn't error correction, but could show up errors from time to time, where there was only ever an even number of holes made across the tape, or an odd number. But if we count here, there's 4 there and 3 there, so that's 7. So that's an odd number. And here there's 2, which is an even number. So that system clearly isn't being used here. As I said before, I'm not totally sure the coding method on this tape, but one thing that was fairly universal was which was the least significant and which was the most significant bit. So if you look at where there's a possibility of only 3 holes being punched, this one here was always considered to be the least significant bit. And where you could have more holes punched, in other words, the 5 here, this one here was always the most significant. So I really should turn it over like that, and if you look at it that way, the least significant bits here and the most significant bits there. So here we've got 1 1 1 0 1 1 1 1, and that would have been read typically by, well, there were methods that used air jets that blew through the holes. There can be little finger springs with an electrical contact on top. But typically it was read optically, and so when light shone through a hole, it could register as a 1, and when no light shone through, it would register as a 0. And then the next thing that had to be done was this 1 1 1 0 1 1 1 1 had to be put into a lookup table, obviously all done electronically, and that wouldn't represent a binary number. It was more a case that that would represent a code for some character that you typed in. And there are a number of coding systems, with ASCII being one of them. Now, what makes me think that this is not EIA or BCD coding is that that always used an odd number of punched holes across the tape, and there's 6 here, so it's probably not that. And ASCII, the ISO code, typically used an even number of holes, and you'll notice here 3 punched across it. So it's not ASCII code either, so it'd be interesting to know what it actually is. But just to make a point, that with ASCII, if you had a 00110110, that would be in binary the number 56. But 00110110 would not represent the number 56, the lookup table would code that to the number 6. Punch cards were used in looms from as far back as the 18th century, with jacquard looms being particularly well known, and embroidery operators are still known by some as punchers. With individual cards being a problem if dropped or stacked out of sequence, cards could be manufactured in a continuous form that was fan-folded for organ book music or for a roll for a player piano. With the advent of more modern computers, data entry and output was needed, as well as storage, and punched paper tape was ideal for this purpose, with programs being quite short and data transfer speeds not being particularly high. As I said, punching the tape was a slower method than reading it. But in fact, when you see a tape reader reading the tape, it really is sort of like this. It does whiz through a little bit faster than I can actually pull it at the moment. It's not a very slow process like this that you might have seen on player pianos or those organs that use those large punch cards, the book music. So getting to the end of the reel here, you'll see some interesting data recorded in the end. And as I said, I don't know what the coding is here, but it's certainly very different from the main part of the data. So I think this is stuff that tells the reader that we've reached the end of the program. And right at the end, there you go. Do you remember I told you about the cutting knives on the punch? Well, this has been ripped off rather like a till receipt, and there we go, the shape of the two knives to show us that this is the end of the punch tape. Punched paper tape found applications in all kinds of data processing machines, from teletypewriters to cash registers and computers to computer-aided machining equipment, to name just a few. Punch tape was used with great success in the code-breaking machines such as Bletchley Park's Heath Robinson machine, getting its name from the artists, and Americans amongst you might be more familiar with Rube Goldberg, who made those wonderful drawings of really complex machines to solve fairly simple and mundane tasks. Later on, it was used with great success in the Colossus machine as well, which ran the tape really very quickly indeed, and also was doing code breaking. Granted, programs on punch cards could have single cards removed to make corrections. Paper tape in its continuous unbroken form allowed for fast processing and ease of handling too. Interestingly, punch tape was also used until fairly recently by security agencies such as the NSA to share cryptographic keys, with tape being stored in tamper-evident containers and being easy to destroy if at risk from discovery by an enemy agent. To enter programs, the famous PDP-1 computer also used a fan-folded version of punch tape, which did not come on a reel but stacked up rather like the way punch cards did. So for a bit of fun, let's do a little calculation on how much data my tape can hold. Now, you'll have to forgive me because I've mixed both imperial units here and metric, but I've got a good reason for doing that. And also, I'm well known for making mistakes with even these simple calculations, so you might want to check my maths. Anyway, my tape is 19 foot long, which is 228 inches. And it stores 11 bytes per inch. So in total, that's 2,508 bytes stored on the whole of this bit of tape. And that's about 2.4 kilobytes, or 2.4 times 10 to the minus 6 gigabytes of data on my little tape. So now let's look at what would happen if we had to store 1 gigabyte of data on punched paper tape. So my tape wouldn't be long enough. We'd need a tape that was nearly 0.4 of a million times bigger, so 417,000 times longer. And that comes to 8 million feet long, and that's about 1,500 miles. So if we had to read that tape, and we read it at 500 bytes per second, so that was the Colossus speed when that was running, and I've just picked a number from there. It would take 2 million seconds to read this, which is a read time of 23 days. Now we've got to get it into the tape reader, so if my tape weighs 13 grams, this gigabyte of tape would weigh 5,421 kilograms, which is a hefty load of 5.4 tons of paper tape to load into the tape reader. So, do you remember using punch tape? Did you program in G-code for your computer-aided machining and then convert it to Mylar tapes like this? If you did, please do leave a message in the comments, because I'd be really interested to read those, and I'm sure other viewers would too. But before we finish, I'd like to show you this rather unusual item that I've got in my collection, and I don't know really exactly what it is. But what I do know is that it punches a very accurate and very precise hole, but just a single one. And it has a wonderful clunk to it, a very clear action. But in fact, I haven't been able to find out what it is, what it was used for. Was it used for correcting punch tape? And there's the Chad going on the floor. It should collect it up here. It's got no markings on it whatsoever. It's not the sort of thing that you could slip into your pocket, so I don't think it was used on trains or what have you. And it seems to have that sort of golden colour that might have gone with computers. Anyway, if any of you know what this is, and if it is genuinely related to punch tape, I do note that the holes that it makes are bigger. So maybe this is a complete red herring. But still, it's an interesting thing, and I'd like to put a bit more history behind it. So I do hope you enjoyed that video and found it interesting. And for some of you, it might have taken you back to your youth when you were working with tapes like this. As you know, at the end of the video, I always leave a few extra bits after I've finished that I might not have cut into this main part of the video. And right at the end, there are a few links to other films that I've made that I think might be of interest to you. Anyway, whatever happens, you know I'll be making another video very soon, and do please join me then.